As we continue through this chapter, there's a couple different things we need to talk about, and that is dose versus day, as well as ranges. So a dose is how much medicine you give in an individual setting, and day is how much medicine you give for an entire day. So one day has multiple doses, and the prescription abbreviations which we looked at, the BID, TID, and the other ones, those tell you how many doses are in a day. To convert from dose to day, you multiply, and to convert from day to dose, you divide. So when you're going from dose to day, you're going from small to big, so that's why you're multiplying, because there's multiple doses in one day. And then to get from day to dose, you're going from an entire day down to just an individual dose, and that's why you're dividing. So next up, we're looking at ranges, and we're going to be looking at safe ranges for medications, and we will be given an order and asked to see if it is safe. If the order is within the range, then it is safe. So an example would be if our range is 0.6 to 1.5 mLs, our order must be 0.6 or larger, but no higher than 1.5 mLs. So it's got to be between 0.6 and 1.5. And it could be 0.6 and it could be 1.5. So it can be the endpoints, and it has to be in between them as well. So an order of 0.2 mLs would be not safe because it's too small. An order of 2.7 mLs would be not safe because it's too big. And 1.1 would be safe because it's in between these two numbers. So next up, I want to look at comparing day and dose orders to day and dose ranges. So make sure that you compare day orders to day ranges and dose orders to dose ranges. And the following diagram is for a problem where the drug is to be administered TID. So let's say for one dose, the order is coming in at 0.8, and the safe range for an individual dose is 0.6 to 1.5. So I want to compare 0.8 to the 0.6 to 1.5. So I'm comparing dose order to a dose range. I do not want to compare the 0.8 mLs to the day range, which is 1.8 to 4.5, because this is talking about an entire day, and I'm only here looking at an individual dose. Now, if you did want to talk about the entire day, because this is TID, if you're taking 0.8 mLs for every dose, and you're taking that 3 times a day, if you just multiply it by 3, then you're going to get to 2.4 mLs. So you're taking 2.4 mLs for the entire day because you're taking 0.8 3 times. And then you would compare that with the day range. To get the day range from the dose range, you would multiply by 3. So 0.6 times 3 is 1.8. 1.5 times 3 is 4.5. So I would compare 2.4 to that. And they should be consistent. So if the dose order is within the dose range, then the day order should be within the day range. So again, the big point is don't compare a dose order with a day range or a day order with a dose range. They need to match. One other thing is that the ranges can be referred to in many different ways. So the dose range is sometimes referred to as the range per dose, or the dosage range per dose. And the day range is sometimes referred to as the daily dosage range, or the range per day, or the dosage range per day. So if it has the word day or daily in it, then it's a day range. Okay. So 13 says find the safe day range in milligrams for a 142-pound patient. So the safe day range in milligrams for a 142-pound patient. The first thing I want to do is to start with the weight. So just like our other questions, I want to start with the weight. 142 divided by 2.2, and we get 64.5 kilograms. So I'm trying to find the safe day range in milligrams. My next thing that I need to do is I need to set up a proportion, and I need to do it with the rate that has a per kilogram. So I see the per kilogram here, and I also see that this is a range. It's two numbers, it's 50 to 80. Whereas this rate here, not only does it not have a per kilogram, but it's also not a range of numbers. It's just the 0.1. So this is definitely the one I want to use first. Now, when you're running through a proportion with a range, you need to do it twice. So the first time I want to do 64.5 times the 50, so I'm ignoring the 80, and then divide by 1. And we get 3,225. And then we need to run through the proportion again, but this time with the 80 instead of the 50. So I ignore the 50. 64.5 times 80 divided by 1. And we get 5,160. So this is currently in micrograms, and they're asking for it in milligrams. So I need to convert and then round. So 3.2 to 5.2 milligrams. And this is the safe day range in milligrams for a patient of this weight. Next, they want us to find the safe day range in mLs. So it's still a day range, but they want it to be in mLs. We have the day range, but our day range is in milligrams. So it's in powdered form, and we need to convert it to the liquid form. So I need to use the solution strength in a proportion. So I'm putting my day range in milligrams in a proportion with the 0.1 gram per 15 mLs. Now I need to have my units match up before I can solve this. So I either need to convert these to grams or convert this grams to milligrams. Either way is okay, but if I just change the grams here to milligrams, which is 100, then I have less work to do, so I'm going to do that. So 15 times 3.2 divided by 100, we get 0.48, and then 15 times 5.2 divided by 100, we get 0.78. And then if I round to the nearest tenth, it's 0.5 to 0.8. So this is the safe day range in mLs. Part C says, would you question an order for 2.1 mLs per day? So this is a day order, and I can compare this with my day range. And 2.1 is way higher than this range, so it's not safe. We do need to be careful how they phrase the problem. It says, would you question this order? So would you question the doctor on this? And it would be, yes, we would question this because it is too much.